Okay guys, here goes a nice FRQ practice problem. So this is from 2012, problem number 3. So I start here, I see a graph. Please note, it's a graph of f. It's not a graph of f prime, it's not a graph of f double prime, it's not a graph of Mr. Height. Okay, it's a graph of f. It's a continuous function. I can see that, there's no breaks. Defined from -4 to 3. Okay, and the graph consists of 3 line segments. 1, 2, 3 line segments, and a semicircle centered at the origin. Okay? Okay, so that function f is given above. Let g be the function given by this. Okay, so guys, what that's telling you is g of x is the integral of f of x starting at t equals 1. So guys, what that tells you is g of 1 equals 0. Because when time equals 1, it's the integral. See, this would be the integral from 1 to 1 of f of t dt. And the integral from 1 to 1, I mean, that's 0 width. So an integral of something with 0 width is 0. So g is the integral of f of x starting at time equals 1. So g of 1 equals 0. And guys, it's a bunch of lines. So, and semicircles. I can compute the areas of that. I know the area of a circle is pi r squared, so a semicircle is half of that. I know the area under a line is a triangle. So again, g of x is the integral of that, and the integral is the area under the curve. And remember, areas above the curve are positive, areas below the curve are negative. This is my starting point, so that's a negative area going forward, but negative areas going backwards are positive because I'm moving the opposite way along the number line. It's kind of like I'm subtracting. So this is actually a negative area. I'm sorry, this is actually a positive area because it's below the line going backwards from the start point. This is a negative area because it's above the line, but it's in the negative direction. Okay. So a lot of intro there. Sorry, talked for a couple minutes. And this is a process you should go through. If you've noticed, I've been doing these things under 15 minutes. There is a little bit of thought that you want to do before you dive right into the problem. Okay, so part A. Part A, it wants g of 2. So g of 2, it's going to be the integral from 1 to 2 of f of t dt. Okay, because look, g of x, it's 1 to x, so x is 2, that's 2. So guys, all that is from 1 to 2, that's this area right here, okay? So let's see, this is 3, -1. So guys, that area, it's going to be, it's below the line going forward, so it's -1/2. The base is 1. And guys, let's see, this is 3, -1. So let's see, it's got a slope -2. So that's going to be, that height there is going to be -1/2. So it's -1/2 base times height. That's -1/4. Okay, so that's g of 2. Okay, g of -2 is the integral from 1 to -2 of f of t dt. Okay, I'm going to flip it around. I'm going to make it the integral from -2 to 1 f of t dt. If I flip the indices, I got to put a minus sign there. So guys, what this is the integral from here, okay, from here all the way back to here. So I've got this triangle and I've got this semicircle. Okay, I'm going backwards. The semicircle is below the line, so it's going to actually be a positive area, okay? It's got a radius of 1, so it's pi r squared over 2, and that's positive. Hang on for a second. You know, scratch that. When I changed the limits of integration. I guess there's two ways you could have done this problem, guys. Let me continue with the way I started it, and then I'll go back and do it the way that I was actually just doing it then. Guys, since I changed the integral to start at -2, so once I flipped the limits of integration and I started at -2 instead of 1, okay, I flipped the sign. So really, I'm starting at this point. I'm starting at x equals -2, and I'm integrating forward. So since that's the start point of my integration, 1 isn't the start point of my integration anymore, -2 is. So since that's the start point of my integration, this is actually a positive area. This is negative. So that area is 1/2. The base is 1, and the height is 3. Now, this area is below the line going forward, so it's minus pi r squared over 2. So I end up getting -3/2 minus pi over 2. You can leave it that way, or you could write pi over 2 minus 3/2. That's the answer. Okay? Guys, what I was just doing a second ago, if I start here and I go backwards, if I'm integrating backwards, areas below the line are positive. So this area is positive. It's positive pi over 2. And this area that's above the line is negative. So it's -3/2. So I flipped the direction of integration, made that negative, so my start point was here. That's what I was doing up here. But if my start point was there, I just got to remember going this way, areas below the line are positive, areas above the line are negative. Okay? So that's part A. It's actually only worth 2 points. This is worth 1 point. This is worth 1 point. Okay? Okay. Part B. Okay? For each of g prime -3 and g double prime -3, find the value or state that it doesn't exist. Okay? So g prime of -3 is the derivative with respect to time of 1 to -3 f of t dt. And if you remember the fundamental theorem of calculus, that's just f of -3. Okay? All I do is I replace the derivative. So if I go back to this, if I had this and I said I wanted to evaluate, so this is the derivative of g. This is g right here. This here is g prime of x. Okay, that's g prime of x. So g prime of x is the derivative of the integral with respect to time. And then, guys, I'd be evaluating when x equals -3. So the derivative of the integral, if you remember the fundamental theorem of calculus, it's just f of x evaluated at x equals -3. So it would be f of -3, which is 2. So that's the answer to the first part. Okay, following in that vein of thought, g double prime x is going to be f prime of x. Okay? If g prime is f, then g double prime is f prime. Okay? Just kind of makes sense. So therefore, g prime of -3 is going to be f prime of -3. Okay, what's f prime of -3? So when x is -3, 1, 2, 3, okay? So f prime, it's the slope of that line, okay? So I go 1, 2 over, I go 1, 2 up. So that slope is 1. So that's how you do A and B. I'll pick up for the rest on the next video.